Good afternoon, ladies.
مساء الخير السيدات والسادة الضيوف الكرام، أهلا ومرحبا بكم في القمة العالمية للذكاء الاصطناعي لعام 2024. وأنا سعيدا أنكم اليوم متواجدون هنا في هذه الجلسة النقاشية. نتناقش عن الهلوسة والتخيل في نماذج اللغات عندما نتكلم عن تطبيقات المحادثات وغيرها من الجوانب الأخرى.
So you know who you've got in front of you, and then we'll get into our agenda. There's no slides. This is really just a guide for the conversation. We're going to talk amongst ourselves, and hopefully we'll get a chance to take some questions as we go along the way. My name is Dr. Scott Nowson. I'm the AI lead for Carney, a global consulting firm. I'm based in the Middle East here. I've been in AI for the last 29 years, in natural language processing in particular, so I'm absolutely fascinated by language models, and having been in chatbots for 10 years now and have seen how bad they can be, I'm very excited about where we are now.
Yeah, my name is Amr Awadallah. I'm from Egypt originally. I got my PhD from Stanford University in the US, and then I started 3 companies. My first company was acquired by Yahoo. My second company is Cloudera, which became one of the largest big data companies in the world. And then my third company right now I'm working on is called Victara. And then my most proudest accomplishment ever, something very dear to my heart and something I'm very proud about, is 2 years ago, His Excellency MBS granted me honorary citizenship to Saudi Arabia. So I'm one of the very few people in the world who are Egyptian, American, and Saudi at the same time.
Wow, fantastic. Ali.
So I didn't establish any company as yet, and I didn't have the Saudi nationality as yet. I'm Ali Abu Snena, first of all, and I am leading the Aramco.ai, so I am the manager of Aramco.ai. Almost all of Aramco AI efforts would land in my table. I moved to Saudi Arabia like 3 years ago when I joined Aramco. I spent the last 13 years of my life before Saudi Arabia in Germany. I was leading some digital labs there, Bochum Engelheim Digital Lab. I spent also a few years as a machine learning researcher by Evonik. Before all this, I did my PhD, my master's degrees, and my bachelor's in England, mainly in computational intelligence and data-driven modeling.
Which university, if you don't mind?
Bournemouth University, Oxford University, and University of York.
Nice.
Hi, I'm Alan Qi from Shanghai and also have office in Singapore. I graduated from MIT and
I can't talk to you, I'm sorry. MIT is such a lousy school.
We're already starting the debate. I love it.
I'm just glad you didn't say
how to
marketing,
be
actually.
nerdy. Okay, that's our term,
Yes.
sentence. Okay, so I was a professor at Purdue University. Then I joined Alibaba 10 years ago, more than 10 years ago. So I was the leading scientist for Alibaba, and then for Ant Financial. Basically, we're building AI platforms for training,
Fraud.
fraud detection, for actually also for recommendation for those type of applications, also for search and online, offline applications. 3 years ago, I left Alibaba and Ant Financial. I became professor at Fudan University, and I started a company called INF. So the INF, to infinity and beyond.
Nice.
Yes, also stands for information. Okay. Yeah. So, so here I am, and we work on how we solve hallucination. That's a problem we think is important for industrial applications.
Yep.
Yeah.
Awesome. Thank you. Professor.
Hi, my name is Mohammed Al-Husseini. I'm an associate professor of computer science at KAUST. So I was born in Egypt. I did my PhD at Rutgers University in computer science. And then after that, I spent also time in Adobe Research, the fundamental AI research at Facebook, which is the organization led by Jan LeCun, the Turing Award laureate, working on basically advancing the AI research techniques. And currently, I was also visiting a professor at Stanford for about a year. And I work in ChatGPT-like technology that can understand vision, visual information. And I'm currently trying to, I would say, exploring, working on bootstrapping a company that focuses just on this. And I'm writing a book called Imagination.
What is it called?
The book.
Yeah?
It's called Imaginative AI. And actually has lots of connection to hallucinations when imagination becomes a hallucination and different applications in material discovery, drug discovery, art creation, video creation. It relates to in hallucination problems and things like that. And when it connects more to other modalities, this problem becomes even more severe when you operate on visual information and maybe speech as well. Yeah, thank you.
My name is Muhammad Ibrahim. I started my career flying satellites. I wrote navigation software for remote sensing satellite in the currently embattled Ukraine. And then I moved into the software engineering industry, building software systems in multiple disciplines from healthcare to e-learning. And then I joined Microsoft Research and worked on localization of search engines and Bing. Back in the day, Bing was like not a big thing. I think it's becoming one now.
Yes.
And then I joined Google DeepMind as a research engineer in 2015, worked on building the robotics software at Google DeepMind. And then again in 2018, I went back to DeepMind and joined them as a research scientist and worked on AI for climate change. I led the research in applying artificial intelligence to make renewable energies a strong contender in the US electricity markets and help fight climate change. We reduced the risk exposure of wind farm owners in the US by as much as 20% over a year and a half. And then I was lucky enough to come back to the place where I spent my childhood and my early years, Saudi Arabia. And I joined a company called Muzin, which I am so proud to be part of. I'm their chief scientist for language intelligence. And our mission is, my mission there is one thing and one thing only, to build the world's best Arabic language machines. Thank you.
Awesome. So hopefully you see that we've got a great panel of experts here, and not to pick sides at the beginning, but I did interview for my first postdoctoral position at Stanford. It wasn't for Stanford, I just happened to be there at the time and took someone's office. So what I want to talk about to begin with is really just to get clear for everyone, because again, AI is just a field generally where a lot of terminology gets confused. Before we get on to really digging into whether hallucinations are really all that bad, let's talk about what actually are there. Can someone give me a concrete definition of what a hallucination from a large language model is?
I'm sure all of us can, actually, and maybe each one of us can give their own variety of it. But first, we can all agree, and I like this, that the session had this in its name, that the more accurate term is actually confabulations. Hallucinations is a wrong way to describe this because it implies like there is some sort of drugs making you high, and that's where the hallucination is coming from. And that's not the case at all. What is happening there is these models, as they are generating stuff, they are probabilistic models. So every now and then, they might fill in the blanks with something that's not supposed to be there. And it's very similar to us humans. We do the same thing. Like, I want you to remember back in high school when you're taking, for example, a physics exam. And you're going through the physics exam. It's a closed book exam, and you want to get very good grades. And you see one of the questions, which you understand perfectly. You understand the question perfectly. But you forgot one of the key process names that you need to finish the question. So as you're solving it, because you're incentivized to solve the question to get a good grade, you just make up a word, and you say, okay, I'm going to assume that this is the name of that missing process or that missing material. And you explain to the professor, I had to make this up because I wanted to finish and I couldn't remember. And that's exactly what confabulations is the large language model is trying to please us, answer us, because it wants to get a good grade. And while it's doing that, there will be every now and then instances where it cannot remember exactly what was the original data, and it will have to probabilistically pick the best guess. And that's exactly what leads to the confabulation thing taking place. And for a more local example, هنا في السعودية, when you're like praying behind the sheikh and the sheikh is reciting the Quran, and then for one of the ayahs, they replace it with another ayah. That's the same exact effect. It's their brain now trying to predict the next thing, and they miss it because they couldn't remember it perfectly. So at least that's my definition. I don't want if others want to
I would
add to
say maybe I would assume most of us here heard about MetaBrain. I remember the very first release of MetaBrain at Aramco. It was not only hallucinating.
What is MetaBrain actually? Educate us on it briefly. What is MetaBrain?
Well,
What is it trying to do?
it's nothing but a large language model specialized on industrial applications. So it was built on top of 90 years of oil and gas data. So I would say it's an industrial grade large language model.
Mm-hmm. So it can speak about oil manufacturing a lot more intelligently because of the input data has a richness of
It
that.
started as a large language model. Now MetaBrain is more of an ecosystem. So it has so many different versions. It has so many applications on top of it. And it has so many experts as well. So there is a specialized MetaBrain versions for supply chain, for HR, for almost all the value chain of Aramco. But back to the hallucination, it was first released. We were talking about, okay, we cannot release it now because it hallucinates. So what does that mean? I was trying to put it like in one sentence or even a few words and say it is when the model outputs plausible, nonsensible output. It does sound nice, to be honest, when you read it, but technically or from a technical perspective, does not make sense. For me, I want to make one very important point here. Hallucination, for me, they existed before large language models. Mm-hmm. For me, hallucination, when normal machine learning models does not obey the law of physics.
Yeah, we call them false positives.
They do stuff. Back then, we don't say they hallucinate. Well, we just try to correct them, but we will dig deeper into this in the coming few minutes.
And it's a very fair point and I think it's a reflection of where we are today. Between us around this table, we probably have over 100 years working in AI. And I always tell people...
That's 99 you, and then we are 1 year.
We've only been cool for the last 2 years. Now, Gen AI, now everyone wants to understand it. Now we're cool, and now everyone wants to talk to us about it. So you're right. These things have existed before, and there's always been errors, but they're taking on a different lens now and entering a more pop culture domain. Is there anything you want to add to the definition?
I want to add one more point. Hallucination is tied with the very nature of LLMs. Mm-hmm. So LLMs stand for large language models, but the language itself is not machinery for reasoning. Okay, there's a paper came out a month ago, maybe a month and a half ago, from MIT. It says, if a patient without the thinking capacity, it can still speak perfectly. And on the contrary, somebody who couldn't speak but can reason perfectly. There are such patients for both cases. It's a perfect illustration. Okay, what we are doing for LLMs are
sorry, clarify again. I missed you. So the patient.
Some patient who can, for example, has a trauma.
Yeah.
The damage to part of the brain.
Yes.
He couldn't speak at all. Mm-hmm. But if you ask him using eyes to make a logical reasoning of inference, he can do it perfectly.
Yes, that's correct. Yes, yes.
Vice versa, actually. Somebody, running some larger systems.
Noam Chomsky is a very famous language researcher. I'm sure you know him very well. He was disproven by this. Like he always would say, language is the origin of intelligence. And this effect
is opposite.
Yes.
Yeah, to a MIT Institute professor statement. But But also, I want to say, they did an experiment on rats. They deliberately remove part of the brain of the rats and see if they can, well, no. But they illustrate that they can see the language region, okay? It's not how to say the rest language, but they can still reason, react.
Yeah.
So that says there's some intrinsic problem. This is biological evidence, but another evidence from mathematical evidence, the paper also saying in the outer space of computable functions defined by LLMs, there are some things you cannot always compute. So you can only approximate. If you force you to give an answer, like you just said, you fabricate something false. So that's hallucination. So mathematically speaking, yes, it's proven.
Yes.
And none of you knew today you were also getting cognitive psychology, neurolinguistics, and a whole range of topics because it's all very related once you get down to it. Right. Is there anything else on the definition you want to add?
Yeah, just one more small thing since we moved into cognitive psychology and neuroscience. I think that us humans basically say things that aren't true for many reasons. We lie, we misremember things, we don't think carefully about what we're saying, we do drugs, or we have mental disorders. Now, machines have no intent, malice or otherwise, and they have very good memories. So we exclude the first two reasons why machines say the wrong things. They don't lie, and they remember. They're very good at remembering stuff. Some people actually went to the extreme and calling LLMs. I don't approve of that, but some went to the extreme and called them huge, large lookup tables. That's not true, in my opinion.
Yeah, I agree.
And the last time I checked, machines don't do drugs, at least not yet. And the phrase mental disorder, when it comes to machines, in my opinion, is an oxymoron. So this leaves us with one, which is they fail to think through what they are saying. And this actually relates to the very good work that Amr has done at Victara in taxonomizing the hallucinations. They're not the same. They're not all created equal. We'll go into that, into the types of hallucinations and which ones of these are solvable with modern technologies, which ones are now, which ones are next, which ones are never.
Yeah. But actually, no, I want to disagree with you a little bit. And I'm sorry, our moderator encouraged us to disagree with each other.
Yes.
No, memory is actually part of it. Like, memory is a very big part of it. So the amazing thing about large language models is how much they compress down information, right? And if they had perfect memory, then they wouldn't do these hallucinations that they do sometimes. The problem is they're compressing down information severely, like in a very, very extreme way. So if you studied information systems and the Shannon theorem proves undisputably that if you try to compress text, the maximum you can compress text and store it in something is 12%, meaning if you were training on 1,000 tokens, then the output is 120 tokens. That means now it's perfect compression, and I can go back from the 120 back to the 1,000 without losing anything. In large language models, we are compressing down things from trillions of tokens to billions of parameters. And by the way, each parameter only stores 2 bits of information. But when you look at this, that means that the compression rate is in the order of 1%. Like, the data stored in the memory of the model is 1% of its original size.
Even with the latest, largest models that exceed 1 trillion parameters in size?
With the largest ones, they're on the order of 7%, 8%. Right? And you can make a model as big as the input tokens, 12% of the input tokens, but that model will be impractical, would be too expensive to run, would consume too much power, et cetera, right? But you're right, the bigger models, and we have hallucination rates that we measure across the model sizes, the bigger the model, the less likely it's going to hallucinate, because now it's more confident and remembers everything.
Yeah, I have to add on this. Sorry, I couldn't help, but add one more point. I couldn't help.
Let's go.
So, compression is actually helpful.
Yes, of course.
We are doing AI. We are not doing compression. So if you do sourceless compression, the entropy, Shannon entropy is the limit for lossless compression.
Yeah.
But to make anything useful for prediction, for task prediction, the theory is the compression itself is learning.
Yes,
Called
that's why it's
MDL,
beautiful. I know.
minimal description length.
Yeah.
So the way, if you can compress the data in a smart way, you suppress the noise.
Yeah.
You extract the intrinsic patterns, relations. So I just want to add a point. It's not just about compression.
This is
It's
exactly what I
too
was
technical, but just want to add
thinking about, because how did we manage to go to what we call now small large language models, quantized models, and we can still keep almost the same performance?
Because what we're doing is we're biasing them. So sorry to clarify this point. There is the notion of small large language models. They're smaller models focused on certain tasks. So what we're doing is we're pushing them to store more information about that task. So they get very good at that task, and they can do it with very low hallucination, but try to use them for something else, and they regress.
Yeah, but
So that's the trade-off here.
This means the what's known today quantized large language models, they are so susceptible to hallucination,
They are, yes.
which we have seen in so many papers that, okay, quantized, but still we are keeping up with the performance of the large language
For a
version
specific
of it.
domain. For a
The
specific
large
domain.
language version of it.
For a specific domain.
I think then we need to talk offline.
One thing I just want to, when we're talking about some of these things, what we talk about with the compression and the way we're representing information, the large language models are trying to memorize a lot of text. So a massive oversimplification. If there are 100 examples of good morning and one example of good hair, the idea is the model should more probabilistically say good morning. The compression might lose the possibility of ever saying good hair. The reason we add more parameters is so that in principle we can remember even those incredibly rare pairs, but there will still be a lot of gaps. So massive oversimplification, but just to that's what we're talking about. Is it really that bad a problem?
So I think what I would say maybe overlap the least with what everything else has been said. So I would think that the context, or when we call something a hallucination, would really depend on the context, right? So when you hallucinate, the hallucination is actually, I think, a feature that we need to embrace as part of how large language model works.
Thank you.
Yeah.
Okay, now
Let
we're
me,
getting into the
let me
argument.
finish.
Let
Let
it
me
finish.
finish. Let me finish. Right. So you may use, for example, large language model to help you write a news story. In this case, you don't care whether.
No, but that's not hallucination. That's creativity. That's fine.
That's creativity.
No. You as a human, you can do two types of novels. You can do a sci-fi novel where you're completely creative, say whatever you do, or you can do a biography about Elon Musk. When you're doing a biography about Elon Musk, you cannot get creative. You have to be factual.
Yeah.
You have to stick to the facts.
I agree, but I think what I'm trying to say is it's context dependent. In the context of, I think that same skill that we heavily criticized for hallucination, in the same skill that enables creativity.
Now,
So I
this
think
is
what I'm trying to say,
I want to ask Amr, how is he drawing a line between, he says, now this is creativity, and now this is
an
hallucination.
alignment.
Very
problem.
simple.
It's an alignment
Let's say you are a patient. Right? I'm the doctor. I'm the large language model doctor, and you're the patient. Okay. And I analyzed you. And I'm sorry. I'm going to make an example.
Okay.
And I figured out that you have depression.
Yes.
Okay. So now there is two ways with me as a doctor to deliver that. I can tell you have depression in 100 different ways that are all correct. I'm being very creative with the language, with the words I'm using, but it's still coming across to you that I need to go now and deal with my depression, right? So it's very factual, it's sticking to the statement and so on. Or I can tell you, I don't think you're a human being. I think you're an alien, and because you're an alien, you cannot cope with the environment around you on planet Earth. You see the difference between these two things? So one of them, I'm very creative with the language, but I'm still factual. I'm picking my words differently, but I'm still factual. The other one, I'm now completely not rooted in facts. And that can be very, very dangerous.
Exactly, and at the point...
but there is a sliding bar, in my opinion, between, it depends on in application. Art, for example, is an unrestricted form of expression. Everybody can do anything. When it comes to a more restricted version of art, which is chair, I want to design a new version of chair. I'm a very big interior design company. I have to create a chair that is novel, different. At the same time, it has to be functional. It cannot be made of paper, right?
Yeah.
I think what I'm trying to say is an alignment problem. This hallucination can be good for some applications. It can be a horrible thing for others, like medical application, as I'm...
I think it also goes back to what Amar was saying about hallucination versus confabulation. So yeah, you're right. It's very much I apologize, all of AI is rooted in English language. We're very selfish. But hallucination is definitely something in the mental
Actually,
space.
hallucination is an Arabic word. Just this is a funny thing.
And we stole all of language.
Hallucination comes from halwasa, which is an Arabic word, just to let you know.
Let's call it imagination. How about we call it imagination?
Imagination and creativity then is headed in the positive direction.
Yeah.
And we're not arguing that that's bad. The other direction of the confabulation, it's not creating new things when new things is the purpose. It's creating new things when something real and grounded.
But the same learning mechanism that enables hallucinations to happen is really the same machinery, right? That enables
the same algorithm, the same learning mechanism. And that's why what we want to acknowledge, at least, that this is an hallucination, whatever we call it, it's an intrinsic feature. Actually, let me say it out loud. This is what large language models should do. And if they do well, thanks to the way we frame the guardrails, the context, the prompting, but naturally, this is what they should do.
But I think you said it should be audited, and this auditing relates to the guardrail that we want
you're
to...
back to reality.
Yeah.
So now we're on to 3 and 4. Why did it happen, and how do we fix it?
No, it's not about fixing. For me, no, I'm still actually saying they are not that bad. Because poor large language models, this is not fair. They are supposed to do what they are doing. So they are supposed to hallucinate out of the box.
That's the key. They're supposed to do what? In what context? For what task?
Yeah. I think in the context, for example, for creativity, you don't need fact-checking, right? I think there is a fact-checking module,
No,
right?
you need
a
it.
fact
You need it.
I am
that's
2
true.
steps back, by
That's
the
true.
way.
I just mean in applications, fact-checking is needed, and this needs to be stronger in some applications than others.
And even
Yes.
in creative. Like
Creative.
again,
Okay.
look at the... First, I strongly disagree. A perfect... No, independent of Victoria. A perfect large language model should only hallucinate if we ask it to hallucinate. It should only make up stuff if we tell it to make up stuff. Otherwise, if I ask it to do a medical diagnosis, write a legal contract, fix or repair an oil drill, it has to do it in the right sequence, in the right way, to avoid big problems.
For a minute, just to comment on this. I'm saying because they are statistical models at the end of the day. They are not outputting the most sensible word. They are outputting the most probable one. Now, you say...
What's the difference?
What exactly? It is the cost function.
No, there is no difference between it. The most probable likely
I
word...
design it. I say my cost function is to do creative stuff. My cost function is for accuracy. My cost function is novelty, and so on. So poor guys, they are trying just to predict the most probable word, not the most sensible one. For me, honestly, I feel like hallucination. No, this is actually the natural behavior of large language models.
Can I have a try to reconcile the two viewpoints?
No, we can agree to disagree.
No, I think there is a way.
But you are happy now, right?
This is what we want to.
I think
I wanted.
from a concrete example that came, it was published in Nature from DeepMind. It's called Fun Search. And the idea there is to unleash the LLM and consider the surreal nature of where it's going a feature rather than a defect.
A bug.
Yeah, rather than a bug. But as long as There is a verifier. So they use it to solve NP-hard problems where the solution is basically is basically infeasible in polynomial time, but you can verify the solution very quickly. And they did that to solve long-standing mathematical problems that have defied mathematicians for decades. And they came up with new solutions because of two things. Because they let the LLM go, and because they had a mechanism to verify what the LLM gives. And the beauty of that paper, I'm not saying that because I come from DeepMind. I'm just saying it because it's really one of the examples where that is actually the reconciliation between I wanted to dream, I wanted to be surreal, I wanted to unground itself from reality, because reality, where the mathematician who was trying to solve this problem for 4 decades didn't get him to the solution that the LLM got him to. So this man-machine augmentation is, in my opinion, the reconciliation between the LLMs hallucinating and the LLMs, we want them to be factual. And this brings us to the taxonomy of hallucination. Hallucination in psychiatry, by the way, is a perceptual syndrome. It's basically when your senses deceive you.
That's why it's the wrong term.
This is the wrong term, yeah. Confabulation, in my opinion, is also the wrong term. Hear me out.
No, confabulation,
Yeah.
if you look at the definition of confabulation, it's making up new words that are not correct.
To compensate for
memory.
loss of memory, exactly.
Yeah.
And I still stand by the argument that these machines have very, very good memories. And it's because they cannot think things through. And here is a thought experiment. If you ask any LLM a very, very sophisticated question, and you ask it a very, very simple question. So the same length of the text for the sophisticated question, the same length of the text for the simple question, and even let's assume, for the sake of argument, that the length of the answer is also the same. But one requires a lot of thinking, and the other is very, very superficial. You as a human, if you are in that situation, you will burn different calories trying to come up with the answer. The machine doesn't. The machine doesn't think. Yeah.
It doesn't think in the same way, but it does think, by the way. It absolutely is thinking. But to go back on creativity versus hallucinations, like one of the big problems that many of us might have experienced with image generation tools is the issue of having 10 fingers or 9 fingers versus just 5 fingers. That is hallucination. That is now the model not being creative. It's being crazy, right? Like, you can change my fingers in any way you want, put them in my ear, put them in my head, but you cannot go make more fingers. And this is the problem that we really want to fix, is how can we make it still be creative, but within what makes sense? So maybe your keyword of sensible is an interesting way to look at it. Yeah.
So this is another technical point. When Ali was talking about how we process the errors and you were talking about validating the results,
Right.
This is typically how we measure AI performance. In more classical machine learning, you might give it data of A or B, it'll classify A or B, and your error function, your cost function is how many did you get wrong? Some of the difficulties we're having now, again, I'm oversimplifying, is what is right and wrong in these language models, and it is context dependent.
There is a paper that came up in the last iClear conference, the top conference, one of the top conferences in machine learning called SILFRAG, right? So the key idea of this is to have a routing mechanism that depends on the instructions that you're trying to give the machine learning model to do. It route, if it needs, for example, to do the fact-checking route, which is RAG related, you need to retrieve documents and fact-check whatever you have produced against the retrieved documents or not. I think what I'm trying to say, what we're talking about is really in principle an alignment problem. You want the machine to follow the instructions that the human is if it's asking you, for example, who was the first man who landed on the moon, that's an information that relates to the history. So this has to be fact-checked. But if you ask it that should go to the fact-checking route. And if the instruction is related to something that's a bit more creative, the same machine can also decide on its own that this is the one that does not require fact-checking.
Right.
I will go and produce a text or the answer directly, or if it's something that is. The other thing also that we need to realize that the internet, the large language model was trained on large chunks from the internet. And who knows, for example, there are also a lot of issues with this. Most of the text in the internet is not written by experts. So, for example, you can learn a lot of information from just the text. But if you want, for example, if you
garbage in, garbage out, like we're saying. Like, and Google was bit hard by this when Google had launched Gen AI within Google Search, and then people were asking it, I'm trying to cook a pizza, and the cheese keeps falling off the pizza. What should I do?
Glue it.
And then it said put glue in the middle, right? And, but that turned out not to be a hallucination. We thought that was a hallucination. It was not. That was, when they tracked it back, was a Reddit post where there was an evil Reddit guy who said that.
Yeah.
So garbage in, garbage out.
But have we moved past how bad they are?
Yes, we have. We have.
Okay.
We've
I
certainly
have
moved
one
past.
thing, one note, one
Because
more
I had
note
a
to say.
zinger for that.
It's not only garbage in and garbage out, but there is also something that relates to the number of expert-related like knowledge. Most people will talk about general stuff, but for example, if I want to build a system for species discovery, this means that I need to have a database of, I don't know, we have 8 million unique species on our planet that we need to characterize what tell each animal apart from one another, how each part describe the size of every part, how, like let's say this has certain size of the gill, color of the beak for the birds and so on. And this information are rarely described in general text on most of the text in the internet. So, for example, some of these cases is actually cannot even done by being selective of this text. It requires labs or experts or from this field, right, to work with you to make these models more actually imaginative, right? Because in order to have a model that can tell you that this is a picture of a new fish that has a gill that is slightly bigger, and that difference is big enough that made this a suspect of being a
It
novel
needs to
species.
go out of the distribution that it has seen before. It needs
And that's
to imagine.
unseen
Yes.
awareness,
Yeah.
basically. And this actually, most of these machines, this is a task, for example, I have, I would say, introduced for the first time about more than 10 years ago. And our best machines up until now really struggle on understanding species that it hasn't seen, despite that they are composed by concepts that we all know. Like, if you want to describe a new species, you will describe it based on how it's parsed and how each part looks like in terms of visual appearance, in terms of geometry, and so on. Our best machines and our best knowledge sources I would say struggle to do this kind of task, and they can't.
That was actually one of the first things that I was taught in cognitive psychology as part of AI. What is a chair and what is a stool? What is a cup and what is a mug? And the notion of concepts. Mm-hmm. You know, when does a mug, which has straight sides and a handle and is probably about that big, become a cup, which is round typically? And so if we don't get it, then there's a place where the machines don't. But I want to get to something that you guys were talking about there, like talking about the fault. On the one hand, then, you know, what I wanted to know is, like, is it our fault? One, as the model builders, because garbage in, garbage out, and you made a point that we need specialist input if we want a specialist model. So is it the fault of the people developing it?
Yes, it's our fault.
But
we don't know the right way to do it yet. That's just as simple as that.
And the other way, though, is it the fault of the user? Because using Copilot, like 3 weeks ago, literally, you could talk to it, and it said, do you want to be balanced, creative, or factual? Which
No,
was
but
the
that's
point.
the temperature. That's different. See, that's
But that was the point that you were just making about which routing it. Should I, as the user, choose it? Am I using the models wrong?
The machine can do that if you
It
train
can,
Yeah.
but how does it know, and am I using it wrong? Am I wrong because I built the model wrong? Am I wrong because I'm using it wrong?
Yeah, I don't like to blame the user ever. The user is always right. The user is always right, and it's on us, the technology developers, to keep improving the technologies to adapt to the user, not the other way around. And that's one of the promises of this new generation of technologies.
I think we talked about 3 different types of faults, if I may call it a fault. One is related to the data, which we can't spend enough time talking about it. Second is the learning mechanism or the algorithm behind it. The third, which I disagree with you, is the context, the prompt, the user. The user can definitely be wrong. If I ask a large language model and say, can cats speak English? In some contexts, or can cats speak English, if I give enough context to the model, then I would expect the model to give like sensible answer. But without enough context, definitely the model should do the natural job.
No, I'm
which
not
is-
talking about
which is
today, I'm
hallucination.
talking about the future. When we build the AGI of the future, which will happen very soon, we expect them to act like you. If I come to you and tell you, can cats speak English? You're going to give me a reasonable response, hopefully. Right? And that's what we want to see happen. That's exactly what we want to see happen. Don't put the problem back on me and say, oh, you asked me the wrong question.
What's
it's
your
fine.
definition of AGI, Amr?
The definition of AGI is a
Another one.
well, I thought it's non-controversial. The definition of AGI is an AI, which is different than
Superintelligence.
superintelligence.
Okay.
Is an AGI that can be as good as humans in any discipline.
Any discipline.
Any discipline.
And you believe
That's why it's
we're
general.
close to getting there?
Yeah, I think we're a couple
How
of years.
many years?
A couple of years. Like
Willing
2 or
to
3
bet
years.
on that?
Absolutely. Yeah.
How much?
2028, 2029, willing to build...
I'm gonna bet
2028.
on money.
Given this definition, you're going to put money on the table.
Put
I'm
money
willing
on
to
the
put money on the table.
Okay.
Okay.
Any discipline,
You're on.
one at a time,
Okay.
or all
We
at
have a
once?
group. So.
I'm putting $1,000 on the table, but how much would you give me back? If
Oh,
I
I know, 1-to-1.
1-to-1, no. I wouldn't take that odds. Because I am on the much risky one, so you have to give me some odds. But anyway, go ahead.
1-to-2.
When you say,
I'll take that. I'll take that.
this is definitely a side topic, but it's a fascinating one. I completely disagree. When you say better than human at any discipline, do you mean the one system, give it any discipline and it's better than a human? Or pick any one discipline and there is a machine that is better at that one thing?
It doesn't matter. They're both the same thing to me. So you have an entity from the outside. It can be modular. It can be made up of many sub-entities inside of. That's fine. But from outside, I can communicate with it in any discipline, and it will be able to meet and beat what we are able to do.
And the same reaction time that a doctor does it, that a pilot does it, in 3 years from
3
today.
years' time.
Okay, you're on.
There's definitely a side conversation. It's not legal here.
Okay, I would say be skeptical for the word any. I would say maybe some disciplines, right, that we invest enough on, we will.
Put money on the table. Yeah.
I mean, the idea of general is that, right? So
Yeah.
the whole purpose of general is it can apply it across disciplines.
If it's in a single discipline, then essentially it's just a very good,
Yeah, like I said, we
narrow
have that. We have
AI. It's narrow.
I think this is a very good topic for a very other
Different
round
round table,
really,
yeah,
because
yeah.
I feel I want to jump, but
No,
but I
it's-
want to go
it's-
back to
Because
the
it was
user thing,
mentioned,
yeah?
AGI,
I know.
in the context.
It's true though, but if we're getting to that point,
So I can
and
ask
we-
AI in the future, make me, like, say, go and make a surgery for
Yeah,
heart
surgery,
surgery.
flying
No,
to
that's
the moon.
robotics now.
And,
That's
That's
AI with
robotics.
robotics.
No.
That will take a bit longer. AI with robotics will take a bit longer, even though that's happening very fast as well, but it will take a bit longer.
in this sense though, if we're talking about getting to that point, then these confabulations, these errors become even more critical. Is the direction that we're moving in then reducing those? Is that,
Confabulations will be solved by middle of next year. By middle of next year, we won't have
all
Oh,
kinds
I
of
disagree.
all kinds of
100%.
confabulation.
Oh, I can bet all this with you. Okay? I can put $1,000 on
Me
the
too.
table.
you heard it here first.
I'm with you.
Yeah, so we can do this
One
back.
Okay.
What I want to say about, again, I want to go back to the user. The user is sometimes wrong. Actually, the user sometimes invites the large language model to hallucinate by the prompt. So that's why.
What do you do if I invite you to hallucinate?
I think that essentially it's
Yeah.
about the definition of users.
Yeah.
Are you developing the fundamental model,
No, I don't
the
mean
basic
the
model,
developer, by the way.
or like the agent, we call agent. The agent will be extension of the LM, okay?
Mm-hmm.
So depending on which layer you're talking about.
No, I'm talking about the end user.
So any user,
Yes.
I'm along with him, okay? But I still disagree on
On the confabulation, yeah.
2 years, yeah.
I
I think that's too optimistic along that
perspective
direction,
comes
yeah.
to many years ago when people were starting to get concerned about Facebook and privacy. It all comes down to the user. Facebook put more and more tools out saying
Yep.
you can control your privacy. You can
Or
control
cars.
your
I mean,
privacy.
cars. Like, that's
Yeah.
why we add airbags. That's why we add seatbelts. That's why we add autopilot now. Like, we're doing that to make it easier for the user. And that's how it should be.
And people
But
will
I
make
would say-
mistakes, but it's on the technology provider
To protect you.
support
But
those.
I was add
The
one
data
more.
layer, by the way. This is a data layer. This is how the data gets generated.
But
For
talking about Facebook, I think one more layer I want to add to that. Essentially, it's not, yes, I think the developers play a critical responsibility. We should be responsible for the problems we create, right? However, the models we build are also reflection of the world, of the human language we created as a human race.
That's a good point.
Okay, for that part,
not
I think
obvious.
you don't have to take the responsibility on your own shoulder. I think Facebook essentially, is actually any online media is a reflection of the problems.
Yeah.
So,
Yeah.
I think this is the
so
only
for
point
that
we
part,
all
I
agree
think,
on.
but that's not user, okay? That's not user, that's the whole internet. Because roughly speaking, LLM is a compression of the internet currently.
Yeah. Yeah.
But there are so many garbage in, garbage out, there's so many garbages.
But in the future,
In
the
the
internet will have also lots of generated text. That's
Today,
another problem.
Today 60% of the
60%.
content. of the
That would be
internet-
more and more. It's a really hard to control that. Yeah.
Should we move on to the solution, or
Yes.
or do you want to take questions from the audience first?
Well,
You decide.
we're going to go on to the solutions. Yeah, we're doing really well for time, in my opinion. We're only halfway through. There's a lot we can talk about with the solutions. But in terms of what are they and what causes them, does anyone have any questions? Is there anything someone said that's prompted a response? Just a quick question. Somebody wants, you shout it out, and then we'll play it back for the audience.
So I have not a concern. I disagreed with the answers to number 2 about what are hallucinations. I think it's, and you actually said it in response to something else, like in the planning world, for example, plans are easy to verify. Optimal plans are hard to generate. So I think it's the same with hallucinations. Everything that these models produce is a stochastic output, that they're all totally equal. There's no difference between any one phrase and another phrase. We are the ones who decide. I accept all these phrases, that's great. But wait a minute, there's a hallucination. I think hallucination is something we perceive. The model always does what it does. And even choosing the word hallucination is putting the model in a place, because hallucination, as you correctly pointed out, is a perceptual phenomenon. What we're seeing is a production phenomenon. And you want to call
Right.
it confabulation. I think confabulation is also wrong. They're all exactly the same. And the only difference is when we
Sorry, the godfather of AI, Jeffrey Hinton, who created neural networks, he's the one who says confabulation is the right term. So let's give it to him at least. Yeah.
Well, it's very controversial.
say, wait a minute, that's hallucination. And the rest of them we like completely accept because they gel with our perception of what's going on. So I think hallucination is totally with our perception. The model does exactly the same thing all the time.
It's a statement versus a question.
Any other questions? Anything someone wants to
philosophical.
know? Yes. Can we grab the mic? Sorry, can we grab over here quickly first? Sorry, there's a mic coming.
There's a mic coming your way.
That was so fun hearing you all. But this is not a question, just something came up to my mind while you're talking. You're talking about hallucination in what? In mind? In our mind? Maybe the machine is smarter than us. Maybe they think we, based on our mind, think what they are saying is hallucination because we don't know. Because they are smarter than us. We need to put their mind and judge them if they are saying something unrealistic or not. Because
Yes
we are
and no,
judging
because
them
there's
based
some
on-
factual, there is facts in life that are undisputable. By the way, you are right.
I
There's
know,
some
but-
cases where that happens.
Sir,
but
let me just
not when it
explain
comes to
myself.
factual stuff. Like, don't show me with 6 fingers. Humans cannot have 6 fingers.
Yeah, I
right? So
know,
that's
I
clearly a
know.
hallucination.
But I think you are creating something. We're not sure about what we are creating with the machine. We think that we're creating something like our mind. But maybe we are not creating something like our mind.
Yeah.
So when we put the limits, we put it against our minds. No, we need to understand the mind that we create, and we decide if that's something making sense or not.
It's true that we anthropomorphize technology. We
do.
treat it like humans all the time. People think Blake Lemoine, who thought the model was sentient and was genuinely expressing emotions, it wasn't. It's just acting. So you're right. The concepts and the mental mistakes we are projecting on it, but we have created it. We know how it works, but the output still represents something that is like that.
I just want
We
to add
don't know
one
how
point.
it works.
We don't know how
it works.
We
We
created
know how
it.
to build it. Well,
Yeah.
we literally don't know how it works. All of us are shocked. Like every researcher in the industry working on this problem, we are shocked that using the simple thing of predicting the next word done at scale can think. Like all of us were shocked about that. Or can draw image, or create a new video clip. Or you can give it an entire mystery novel, and you can have a crime that took place and lots of scenario and lots of scripts and a very complex novel, and at the end of the novel, it says, and the killer was, and you leave that blank, and it would read the whole thing and give you the name of the killer at the end of the novel.
To me, I want this point linked to the compression idea you mentioned at the very beginning. When you say thinking, okay, we're not clear if the current LM is really thinking. Maybe it's just repeating.
Yeah, it's very good at pretending, mimicking.
This is like to a kid. The parent is so logical, so knowledgeable, knows everything. Just because we know more doesn't mean you are smarter. We're smarter than a 7-year-old, actually.
Yeah.
So to computer, maybe it compresses all the information on the internet.
Yeah.
To any human being, it looks like, oh, it's so knowledgeable and it's so reasonable. But maybe it's not really thinking. To be a real thinking machine, I think it needs to understand, actually, concepts, extract new knowledges, discover unknown patterns or rules, like AI Einstein. I think that if that happens, I would say that's a real AGI.
Yeah.
Put aside the emotional side, okay, the artistic part, okay. I'm talking about AI Picasso or anything, but talking about AI Einstein.
No, you're right.
That is not a compression of the internet. Currently, there's no way we couldn't tell if just repetition.
Yeah.
We couldn't tell. Just like the computer is like a we to a kid, to our own child.
So you're right. We're projecting human things, but we're also getting very into the matrix. They're like, recreating.
Okay, let me give a couple of examples where I believe that there is a lot of gap in really our best machines. There are recent experiments, I believe, by a professor at the University of Washington who just tried to see how good machines are in the next token prediction, I would say, mechanism is good at multiplying numbers or something like that. They struggle too much. You need to really simplify it for the model so that it learns how to use a calculator or a tool or something.
But in other areas, they do amazing things. You can tell it, code for me an application, write for me the entire code for an application that is like Snapchat, and it will do that for you. The front end, the back end, the middle, like the whole thing. How is that not thinking?
No, that's not thinking. That's based on resemblance at best.
No,
because the codes like this exist.
Mix and match, but they're
It's a
not existing.
distribution.
That's what I meant by
I think
Einstein.
Huh?
Relativity theory doesn't exist.
Exactly.
Didn't exist before he
Yeah.
proposed that.
Yeah.
No, actually it does exist because thanks to the richness of the data that fuels and powers those large language models.
No, he's
he's talking about relativity. He's talking about Einstein.
Like
and,
Newton seeing the apple fall, and then he comes up with the laws of gravity. Like that's just like next level. Like, there's no data. There is nothing in there.
There's some data, very few data points.
Yeah.
What he's saying the computer, the LM can write programs, the code, but it's perhaps just repeating whatever in the internet already.
Mixing and matching. So
Maybe in the
it's mixing and
GitHub,
matching.
right? It's a mix and matching. Yeah, it's a combination.
Yeah.
But what if you can do something never existed,
Yeah.
like relativity theory before
But
Einstein?
even us cannot do that. Like very few of us humans.
That's called creativity.
No. It's
called
another level.
intelligence.
It's another level.
Yeah.
Like
It's
most
called
of our
intelligence.
the average person, including yours truly, our creativity is all about mix and match. What we learned in the path, our experience, and how can we take snippets of it and put it together in a new way.
I agree.
But there is few of us like Einstein, like Newton, like Mozart, like Picasso, who they just jump over 10 times. They come up with things that none of us existed in the past to make it happen.
These machines make mistakes that my 4-year-old wouldn't make. getting to Picasso and Einstein is a huge leap of faith.
I can give an example.
You're right.
So many examples that exist there. There is a paper called Alice in Wonder World.
Okay.
Simple paper that have puzzles that I tried on my 4-year-old. He got 80%. ChatGPT or GPT-4 got 1, 2, 3%.
Yes.
And this
That's
goes
a
back
reasoning
to
problem.
That's a
of
reasoning
ChatGPT.
problem, yeah.
It's a critical problem for next step development of LLMs.
Yeah.
That's also tied to hallucination. Yeah.
And this goes back to
very
you,
core
Amr,
problem.
when you were saying, actually in a couple of years we are getting to the AGI. I know this is another big debate, but how on earth are we thinking that way when we don't even understand how these basic LLMs are working?
Because sometimes you don't need to understand how something is working to take advantage of it. And then the other part of that is these things are getting so close right now to being able to improve themselves. Like they're coding at a level that is getting advanced at an insane speed. The coding skills we have today from a year ago is a massive, massive difference. If that keeps happening, then they now will build their next version that we won't understand.
Yeah, this is the thing here. Me personally, I look at it, this is basically nothing but information encoding. Again, thanks to the rich data that's out there. How much thinking, how much creativity, how much intelligence into this, it's just debatable.
How do we measure that?
Alice in Wonderland.
We've got a question at the back here.
Okay.
Thanks. So I encourage you, the moderator, to be a little bit more moderatorial. There's some great ideas that need to come up from the various panelists. Quickly on the intelligence question, you mentioned that your son could solve some puzzles that the large language models couldn't. And I guess you must be familiar with the work of Francois Cholet, the French
ARC.
the ARC, which
Yeah.
is looking at exactly this and making some encouraging progress, not by large language models, but by different kinds of AI altogether. And I'm sure in the future that kind of rational systems can be married together more creatively with large language models. But that brings me to the question I wanted to raise, which was something you also raised, Mohammed. You mentioned, I think, a very interesting example of an AI that came up with creative solutions to mathematical problems that had foxed human mathematicians for 40 years. I mean, could you explain a little bit more about what that was? What kind of mathematical problems were they? Were they very obscure things, or were they real-world mathematical problems? And was it the combination of creativity on the one hand, coming up with new ideas, but then a critical faculty as well that could figure out which of the creative ideas had some real value in them?
Right, thank you. So I cannot explain fun search and give it its due right. The paper is called Fun Search, FUN search, and it's on Nature. But at a high level, but before I go into the high-level explanation, I must emphasize that it was, as anything else that comes from blue-chip tech giants, taken out of proportion. So this is not coming up with new math. This is, and the problems solved there are not really those that are the most challenging. The problem is called CAPSET. And this is one of the 4 problems they tried, but this is the one that I like. And the other one is basically BIM packing, basically. So it's a concrete optimization problem where you need to come up with a discrete solution. It outputs code in Python. The solution to the optimization problem is in Python. In the beginning, they start with a skeleton, where the skeleton has the human heuristics. That mathematician bootstrapped it. Without that, no chance. This is the expert input that Dr. Mohammed spoke about. So expert input as the skeleton of an initial Python code that goes into the LLM that acts as an evolutionary algorithm. It does the mutation and the selection, the pseudo mutation and pseudo selection. DeepMind didn't publish the exact details of what happens inside, but they just say it's an evolutionary algorithm. And then the LLM, you ask the LLM through a prompt to come up with 10 programs that does better than the initial heuristic. It comes up with them. Now, you can verify whether each of these actually solves the problem, if not the most optimal. But is it a solution or is it not? Is it a better solution than what was before or not? So it gives it a score and it puts it in a pool, right? And then comes the selection algorithm, and it selects the top two, mom and dad, in an evolutionary sense. And then it takes those, it gives it to the LLM. The LLM comes with an offspring that's hopefully better. So the LLM mutates the code, mutates only parts of the code, not everything in the code, mutates the critical part of the code in ways that us humans may never thought of mutating the code. And then here is the gotcha. The mathematician looked at the pre-final versions of those. They weren't even getting close to the optimality point that the mathematicians found themselves. And then the mathematician looked at the code because it's interpretable. Now here is going back to whether they are fully black boxes or not, and code is really something impressive, to be honest. Their ability to code, I admit, but it's a context, it's a CFG language. It's not an ambiguous language, so that's a whole other story. But he was able to look at the code and say, why is there symmetry here? I never thought of that before, because it's interpretable. And he modified manually the next generation, and then came the breakthrough. This man-machine augmentation, in my opinion, is the future.
Amazing.
Can I add on this point? So actually, there's a book, Thinking Slow and Fast. So for neural nets, it's essentially the black box. For logical reasoning, it's a white box. So actually, in 1990s, expert system was super popular, right? But they couldn't work out because the rigid rule systems is not scalable. But you could put them together. That's exactly what's in the human brains. So essentially, you are putting random explorations like LLMs together with reasoning. You can do reasoning step by step, like proving a theorem. You can do many steps reasoning. This is not like a autoregressive LLM does. So put them together. That would be super helpful. Second, you can also explore like reinforcement learning or other technologies to explore the space, like what it's saying, like an evolutionary algorithm. It's basically search algorithm.
Yeah.
To search all possible combinations. But if you do that, you can have more reasoning capacity. The problem of that is that, of course, I believe that's the future. I coined a word, I call it a gray box approach. It's not black box, it's not white box. The word is not black and white, it's gray. It's a gray box. But the problem is computational cost. For any real application, talking about the foundation models, they care about the cost of inference. That's why small language models are getting popular. If you do reasoning, do any reinforcement learning, it's super expensive. It really cost demanding, okay? But you can, again, use LLMs, like what we discussed at the very beginning. It's a very good compressor. You can compress what like a reinforcement learning or planner does as a compressor. If it does that well, you could have more reasoning capacity in the future, at the same time maintaining low inference cost. That's very technical, but at a higher level, essentially you're combining two types of thinking.
System 1 and System 2.
Yes, System 1 and System 2. Well, I didn't want to go to the jargon. It's called System 1 and System 2. Put them together and in one system. And that will be, I think, the future of AGI.
Wholeheartedly agree. Yeah.
Yeah.
So thank you for that question. We went down a really good path there. And that actually gets onto, once we start getting technical, once we start addressing these issues and looking to the future, how do we fix this situation? And when we talk about, we're just going to throw quotes around hallucinations now because we use the term, we're ingrained in it now. But one of the most popular terms of the recent times, one of the most popular approaches is RAG, Retrieval Augmented Generation. I know Vectara have done a lot of work on this. So
I mean, all of us. I wouldn't just take the claim as Vectara. But retrieval augmented generation, to simplify it for everybody in the room, remember the example I gave you earlier of you taking a physics exam, and then it's a final exam, it's closed book, and you really want to get a good grade, you're incentivized to answer everything, and you end up making the name of that process because you couldn't remember? How do you solve that problem for a human? Like after they finish the exam and go in the real world, we do it open book, it's not closed book, meaning we let them analyze the data, try to solve the question, and if they can't remember something, they can open the book and look, oh, the name of this process was Newtonian physics, whatever. I'm going to add it to the answer, and I get my perfect grade. So that's exactly what retrieval augmented generation is. So retrieval augmented generation is, let's augment the LLM with a full fidelity brain for the data set that you care about. So for the data set that you care about, for the lack of a better term, because I don't want to go over a long description, we encode it and put it inside of a system, a database, that is able to find all of the facts, find all of the needles in the haystack relevant to your prompt, relevant to your question. And then after it does that, finding them not by the old way of doing search and keyword matching. That's like a very old way of thinking. No, it's finding them in the same way you would find them, meaning it's matching them based on your understanding and comprehension of how useful is this fact for this question that the user is asking. And then once we find all of these needles in the haystack, the facts, we give them to the large language model. And then we tell the large language model, hey, large language model, your job now is to answer this question, but only use these facts. Don't use any of the facts in your brain because I don't trust them, because you hallucinate all the time. Please use the facts I'm giving to you right now. And this reduces the probability of the system of making mistakes significantly. And it does have secondary benefits. It's actually very good for security, for access control. It's very good for explainability. As it's writing out this answer, it can give you citations. This sentence came from these 4 documents. This sentence came from these 2 documents. So you have proof of the correctness of that response. So that's what retrieval augmented generation is. The industry, all of the industry now is agreeing it's one of the best ways to minimize hallucinations in large language models. It's not the only way, though. You want to augment it with other things. So one of the other things we do at Victara, and I would like to hear the thoughts from Alan and others, because I know his company works on this problem as well, is to tune the model itself to hallucinate less. So you can take the large language model and do DPO optimization on it to make it incentivize it to not answer when it's not confident. Okay. So instead of giving you an answer that might be off, it will say, I'm sorry, I cannot answer this one. And that will make it less creative, by the way, when you do that. So we did that at Victara. It's a model called Mockingbird that we built ourselves, and it significantly reduces the probability of hallucination. When you put these 2 things together, our effective rate for hallucination right now is around 0.5%. So that's why I'm saying that remaining 0.5%, we will solve that within the next year.
Oh my God, no.
But this 0.5% is according to
This is a
They have $1,000
This is a
batch
test that
already?
got 99.5 on that test, and I know that test
Yeah,
very well.
but the remaining 0.5%, what we need to do is to say no. Like there's a big, all that the business users want, we work with many banks and telecom companies and health companies and governments. All they want is, when you give me an answer, I want to know the answer is correct. And if you don't know the answer, I'm okay with you telling me no.
Yeah.
And that's
But
the
I
thing.
think-
How do we get to say no?
I think what he also means is that maybe this 99% is one item in
one
the
type of
dashboard
that
we are missing maybe 10 other items that we are not measuring in that benchmark.
That's exactly
That's
what I'm saying.
99% is in one dashboard.
One way,
So
the factuality confabulation is just about, if I have the answer here somewhere and I know it's there, I just want to make sure that whatever the LLM says is there. I'm familiar with HHEM. I'm familiar with the work, amazing work that Victara has done in this regard. And it's solving non-factuality in a very good way. But what really makes me think is that when I look at the leaderboard and I see this 0.5%, this 1%, this takes us back to what really could go bad is that sending an upstream signal that confabulation and hallucination has been solved. When in reality, it's far from being solved, given that when you ask simple questions that require very simple reasoning, or when you change the numbers from their numeric transcript to their word transcript, and the model just gives you a different answer, and then we say we're only 1% close to solving confabulation?
So you're right, so let me rephrase my statement. Solving it for a given data set.
Yes.
Okay.
For a given data set, not for open-ended questions.
Yes.
Okay.
This brings.
Okay, go ahead. You first, and then.
Because I was thinking about when you were talking about RAG, everyone knows the great stuff that RAG brings into the table, and also the simplicity of solving and how significantly we can reduce the hallucination.
And explain things.
Yes.
And enforce access control.
Yes, but I think as researchers, as scientists in this domain, in my opinion, we should spend and emphasize enough time on, we go 2 steps back and spend enough time on the data itself.
Of course.
Cleaning, making sure there is no conflicting information there is no redundancy there. And I think we recently started to see some even small companies that does this service. Still huge efforts are still needed or expected in that area.
Yes.
And at the end of the day, combination between data, learning mechanism, techniques like RAG will all bring things together. And
I agree on this part. I think the causes of hallucination is a multiple fold. It's a complex. It's not a single factor. Okay, so we need data cleaning. It's so obvious, right? Better data, higher quality. Even with high quality synthetic data. Okay. Number 2, new technologies. I think we need a new technology. If we stuck with LLMs, just doing autoregressive transformers, we will get stuck here. We will not solve the problem, no, regardless how clean the data it is, okay? Regardless of how clean the data is. I mentioned that the integration of type 1 and type 2 systems. Essentially, the integration of neural nets, transformers, with logical reasoning, okay, with reinforcement learning, put them together. I think that is the future, okay? At least one possible solution for that. Number 3 is verification. It's like reflection, right?
Yes.
It's like once there's a sentence, I would think, oh, if I'm wrong or not. It's like people even argue that's a definition of conscious, right? You know what's going on while you're talking. So if the machine can re-examine what's speaking, verify the process, in the process.
While it's working.
While
on
it's
the
working,
data. Okay.
you just check the process. While it's working, then you have a higher chance of being correct. Just like watch your mouth while speaking, right? So that is the third possible technique. People are exploring that. There are new technologies are emerging along these directions. I think it's, as I said before, it's not one shot. You solve it altogether. You need a combination. It's like solving a cancer tumor, right? It's not one thing you get done. It's a really hard problem. Yes. Yeah, I think RAG is really super useful, practical, effective, simple, yet not sufficient to solve the whole problem. It's a remedy. It's not a solution. A comprehensive solution. What we need is a rethinking of the technology from the data to the algorithm to the examination. The whole thing needs to be redone.
But RAG does not exclude that, just to be clear. Like for example, in our system also, and Mohammed, thank you for mentioning it, we do have the detection stage, right? So we do have a model called the hallucination evaluation model. It's actually the top model in Hugging Face right now for hallucinations. If you go search there, and we published the leaderboard with that. And what that does now, it gives us quantification for every response. So we know when the system is hallucinating or not. The optimizations that we did to the LLM with DPO to make the LLM itself incentivized to hallucinate less. Part of that is looking at all of the inner layers and propagating back the feedback from the inner layers to the last layers to be able to punish the system when it's the inner layers are starting to randomly take you down the wrong path. So I agree with you 100%. There's no one answer, and I like the analogy of cancer. I don't like cancer, but I like the analogy of cancer. We have to deploy all of the tools at our disposal to fix this problem.
Right. This symbolic and sub-symbolic, this is what I like to call LLMs, sub-symbolic machines.
Why?
Because they don't think at the atomic unit of meaning. They fuse the meaning in a very, very high dimensional space. So there is no atomic separation line between one concept and the other. They tend to fuse in high dimensions. So this symbolic and sub-symbolic, people call it neurosymbolic. It's been there since the 1980s, and everybody thinking, how can we actually marry these two unmarriable
But now it's happening. Neural nets were dead for decades, okay? It's like once you have all the engineering efforts, resources, things could be different. This time, I think neurosymbolic will rise with a good chance.
I believe so. I believe
That's
so.
my personal bet. I can bet $1,000.
There you go.
This is the bet,
And maybe the linked, maybe
Yeah,
that's the
yeah.
only way.
So
There is a recent paper called GraphRag, right? That
yeah,
does exactly.
GraphRag is basically it's
Just RAG. GraphRag
it's
is just
rag.
RAG.
It's rag on a
If
graph.
you have the graph, use it. But the problem is building graphs is so hard. Like anybody in the graph business, I mean, I worked at Yahoo, worked at Google, like you will have to maintain a graph for every single language you're dealing with.
Yeah.
You'll have to have a graph for English, and then a graph for French, and then a graph for Chinese, and then a graph for German. The beauty of embedding models by doing embedding into a vector space is they auto-generate that graph for you dynamically from the data itself. But of course, the hard part for it is you need a lot of data to create that graph. That's kind of the...
Yeah.
But if you have a graph, use it. It helps.
Of course, but one point on GraphRag is that what it does is that it does global retrieval versus local retrieval, which the typical RAG does, where when you have a graph, as Amr said, it's really difficult and they're fragile, and there's this work that's going on right now to improve that, of course. But if you search on a graph, you transcend the passage or the document boundaries when you are...
I agree.
Yeah.
If you look at OpenAI's official website, there's a report like last year. This is GPT-4. They outperform all the other methods except on reading comprehension and arithmetics. And the method outperformed GPT-4 is by our team. Our team, actually. We actually did attention transformers on graphs. Just give you credit, okay? Graphs could be helpful.
I think
Actually, we use attention mechanism on graphs.
The point here that when you present the information in the form of graphs, it represents how we interconnect concepts in our brain. And so you're making the knowledge in a...
Mind maps.
Mind maps, exactly. Yeah. So in a more digestible, I would say, format that is easier to operate on.
I think the good news about all this, and by the way, this is also my hope. I'm not heavily relying on transformers, by the way. Yes. And I was so happy to hear recently, I forgot his name now, the guy who published LSTMs, and he proposed XLSTMs now.
You against Schmidt-Huber or
His
Alex Graves?
I think his student, you mean?
It's okay, it's okay.
No,
Names are not important, it's okay.
He's actually the colleague of Jürgen.
Okay. At Kaust.
Yeah.
Okay.
He was saying we will get rid of all this once we all realize that transformers are nonsense. And that's where he proposed the XLSTMs, long short-term memories. The message or the point I'm trying to make here is rethinking the current algorithms that we have, rethinking the technologies. I very much liked His Highness this morning when he was saying the amount of, or His Excellency, the amount of intelligence we human beings have does not consume more than 20 watts when it comes to power. Imagine how much intelligence do we need today and how much power do we need to empower.
So I agree and disagree with him a little bit. We consume a lot of power during learning. We spend 20 years learning to be able to be productive at something. That's a lot of power consumed, and money and resources and everything. But I agree with the inference. Like once you finish learning and now you're doing stuff, yes, we burn a lot more power. And there is lots of research going on right now that you might be familiar with that's leveraging biological neurons to do the inference instead of
through spiking neurons.
Yes.
Yeah.
And that might bring down the power. And then there's analog designs as well now that I'm seeing very, very promising power reduction for it. So we're going to improve on that side.
And it's interesting how much this always comes back on itself, and the point you guys were making, neurosymbolic, and I follow Gary Marcus very closely, and I'm more on that side of skepticism, I'll be honest. But
I'm with you there.
There's new techniques that are old techniques. The whole point of deep learning is, neural networks were invented a long time ago. The concept was there, but now we have so much data and so much computational power, we can do incredible things with them. And I want to we're getting towards the end.
I think this is
bit.
like, for example, through knowledge graph, we'll know that humans shouldn't have more than 5 fingers, for example. One of the funny examples I was playing with, or I've seen, with DALI, like this image generation tool, right? If you ask it to generate, I think someone was trying to generate an image of a bowl of ramen, and then I'd ask it DALI generate the bowl of ramen. He didn't like the chopsticks. He want to take them off. He asked the system again. I want a bowl of ramen without chopsticks, and then it generate without the chopstick. It didn't listen to him. And then asked, I wanted this bowl of ramen with fork, and then it with a fork instead, and then it generated with a fork and chopsticks. And then ask it, show me a pair of chopsticks. It generates the picture of chopsticks. I don't want these in my bowl of ramen. And so the point here is that what I can, given my understanding of the visual, the reason why this system didn't work is that the model doesn't understand the concept that in this case, for example, just understand that the pair of chopsticks is part of the pair of ramen, right? So this association is something that is formed, that are formed in our brain in knowledge, in terms of our experience, in terms of our using. These are all sorts of knowledge that large language model have no chance to learn, right?
Yeah, and the godfather of AI told us 7 years ago that radiologists are not going to be there.
Yeah.
Musk told us that level 5 self-driving cars should have been there 3 years ago.
But they're there now.
What we have to, level 5, no.
No, level 5 is there now.
They're not approved.
What do you mean? Waymo in the Bay Area? Come visit me in the Bay Area.
Yeah.
I'll take you on a Waymo ride.
We have radiologists driving to work today.
Okay, I just had that same discussion, interestingly, with my AI lab lead, who does more on the innovation and research side, and the whole concept that an LLM is nothing like a vision production model. I was trying to create an image of an Arabian desert, and I kept getting cactuses. And I would say, no cacti, no cacti. The concept of no doesn't make sense to it. But anyway, we've got 10 minutes left. I'm going to go back around the other way for sort of closing consideration. So no pressure, but you're going first.
No problem.
In the space that we disagree on a lot of things, I think we agree on a lot that context is important, that there's human elements and machine elements. But what do you want people to take away with in terms of where we are with hallucinations? And what are we doing about them? Are we fixing them?
Right. We need not ridicule how far us humans are going to be forever different than machines. And we need to understand that machines will always augment humans rather than replace them. And in my personal opinion, AGI is a myth.
Oh. I like part of it.
You can respond in a second.
Okay. So on the, I would say the positive side, I would say we have made very promising progress that I think as a humanity we should be proud of. But in the meantime, there is a lot of work that needs to be done to make this technology more useful for society, for practices. We have seen ChatGPT, most people use it for some tasks, but how much of this technology is used in hospitals? Pretty much, not much. I and Collaboration Studies released recently MiniGPT Med, which is showing is the best model, better than the state of the art by 10%. But of course, it needs to be informed by radiologists and things like that in terms of making it actually go to the hospital, convincing the healthcare practitioner and guide the development of this technology in a way that solve the pain points by these practices, how these technologies are used to retrieve information, to facilitate or improve maybe the monitoring of crowded scenes, like in Haram or something like that, to detect people who, find lost people or something like that, or maybe find people who needs help while they are riding up an escalator or something like that automatically, and maybe stop the escalator from moving if someone is struggling. So I think all these kind of systems does not exist yet, and there must be a reason why they don't, right? I think all the efforts to build that are not there yet, and I think the system really struggle in anything that relates to combustionality, anything like the example of the bowl of ramen is the thing, but I think I have seen that very true in the species discovery problem. The best machines in few hundred species, they struggle. They don't really do well at all on understanding unseen classes, unseen concepts. So if you ask it, I have a class that has this kind of beak, it has this kind of legs and has this kind of plumage on the back, on the head, or something like that, and you've described very precisely what species is this, the model won't be able to do it. We need conversational models. For example, as Amr said, for example, sometimes the user is always right, I agree with this, but the user sometimes provide, let's say, ambiguous instructions. So maybe describe some bird, but he's not precise enough, and then the model needs to come up with questions to ask what the user really means until it gets precise enough that the system provides an answer. How do we align it with different, let's say, countries? If we have a system that is instructive, we have a system like in Tesla, you want to ask it to stop by the lady on red in the future. We don't have such a system yet. Or maybe turn right while on red. This is okay in the US, but not okay in the UK. So basically, how do we give the system a code or a bit, let's say, a code or a law and ask it to follow it or something like that? So how do you solve this alignment problem? I think we don't have really good solutions for this at the moment.
Okay, so to summary, for my point, I would say we need to solve hallucination. Okay, I think we need to integrate neural and symbolic inference to develop trustworthy foundation models. If we have trustworthy foundation models, then we can have AI doctors, AI financial analysts, we can have AI architects, we can have AI engineers, and AI artists with plotting people with 5 fingers. Without solving that, we're gonna live in a society full of misinformation. Look at the social media, so we will be concerned because we don't know what is seen by a robot in the news, in the websites, in information while being received. I think that's really, really important for future society. Okay, that's my view. And if we do that well, in the future, we can also use AI for weather forecast, for drug design, for better energy production, for curing cancers. So, solve it.
Ali.
From my side, I want to summarize with 2 points. One, I want to go back to question number 3 and answer it the very crisp answer. Yes, it is our fault. Basically, because these models are our output. These models are basically built on top of data that we generated. And that's why I have a lot of concern when I hear responsible AI, ethics of AI, trustworthy AI, all this stuff is our.
Let's solve this first. I agree.
So this is one. The second is the AGI, how far are we? Is it a myth? Is it in a couple of years? Last week, I was part of the autonomous racing Indy Challenge in Indiana. And the University of Virginia, they were doing a great job. Their autonomous car was running at 171 miles per hour. And when we went to the second stage...
Level 5? Level 5? Like no driver?
No driver. But look what happened when we went to the second stage. Two cars were driving against each other. And unfortunately, a bird, it just came in front of the camera. And the car thought this is a wall.
Oh, my God.
And it drifted, crashed, and lost control.
Oh, my God. Yeah.
So, AGI, when, where,
But
is it a
what would a human have done, though, if a bird came on their eyes?
Panic.
I wouldn't have crashed.
Straight to the bird.
Yes.
Thank you, Ali.
Yeah. So actually, I have first a message from my sponsor, meaning Victara, a quick ad for Victara. But then a funny hallucination thing that happened to me yesterday on Facebook. So that's kind of what I'm going to conclude with. First, for Victara, very briefly, if in your organization, if you're looking to deploy AI assistants that are reliable, that don't hallucinate for your use case, not in general, that are secure and explainable and unbiased, please come work with us. That's number one. The funny thing that happened to me on Facebook. So Facebook just launched a very cool feature in Meta, if you have not tried it, where you can go in Messenger or WhatsApp to the Meta AI agent and tell it, imagine how I look as whatever you would like. And you can say, imagine me as an astronaut, as a gymnast, as a swimmer. So I said, imagine me wearing a Saudi aqal on my head. And you know how McDonald's have the McDouble, where they have these two patés? And so the hallucination that came back was a double. It looked very funny, like there's two of them, like a tower on top of your head coming down. So that was my most recent hallucination. I don't know if that's a thing. Does that exist, where you can put like
So many of these? No, I don't think.
right?
Does anybody do that? No.
Yeah, so I think that's complete hallucination.
Oh, okay, okay.
Okay, thank you, everybody. Hopefully you learned something today. Hopefully we disagree on a lot of different things. I don't believe in AGI either. But I think
3 years, we have this panel again.
Okay. Someone
Yes.
book us in for GAIN in 2027. Same room, same group. We'll have this debate again.
Yeah.
The godfather of AI, also from University of Edinburgh, which is I went, so
Nice.
I disagree with him too. But yeah, hopefully you've learned something. There's a lot that we've done, a lot of progress we've made in this space, but there's a lot still to be done, and it's still one of the most exciting fields I can possibly imagine. And yeah, we'll see you all in 3 years.
Yeah.
Thank you,
very much.
everybody.
Thanks a lot.
Thank you.